Picture yourself standing on the deck of a research vessel as it cuts through the icy waters of the Antarctic Ocean, surrounded by towering icebergs that have drifted thousands of miles from the world's most mysterious continent. The air is so cold it burns your lungs, and the silence is broken only by the distant crack of ice shifting in ways it has for millions of years. What you're about to discover challenges our understanding of life itself and reveals how Antarctica continues to surprise even the most experienced researchers. Just months ago, scientists aboard the Schmidt Ocean Institute's research vessel Falkor made a discovery that sent shockwaves through the marine biology community. When a massive iceberg detached from the Antarctic ice shelf, it revealed something extraordinary hidden beneath. For decades, maybe centuries, this section of seafloor had been locked away under solid ice, completely cut off from sunlight and the outside world. What researchers found there defied every expectation they had about life in extreme environments. Using advanced remotely operated vehicles, the research team descended into waters over 1,300 meters deep, deeper than most skyscrapers are tall. Their cameras revealed a thriving underwater ecosystem that shouldn't exist according to conventional understanding of marine life. Massive corals and sponges, some the size of dinner tables, carpeted the seafloor in vibrant displays of color and life. Giant sea spiders the size of dinner plates moved through this underwater garden alongside icefish, perfectly adapted to sub-zero temperatures, and octopuses that seemed to thrive in conditions that would kill most ocean creatures within minutes. The implications of this discovery extend far beyond marine biology. This ecosystem had survived in complete isolation, potentially for thousands of years, developing its own unique evolutionary pathways. The organisms found here have adaptations that could revolutionize our understanding of how life persists in extreme environments. Knowledge that becomes increasingly important as our planet faces rapid climate change. But this discovery represents just the latest chapter in Antarctica's ongoing revelations about life, climate, and the history of our planet. Recent NASA satellite data has revealed something equally unexpected about the continent itself. Despite rising global temperatures that have caused ice loss in many polar regions, certain areas of Antarctica have actually gained ice mass in recent years. This temporary anomaly, while not contradicting climate change science, reveals the complex and sometimes counterintuitive ways our climate system responds to global warming. The mechanism behind this ice gain involves changes in atmospheric circulation patterns that bring more snowfall to parts of East Antarctica. However, scientists emphasize that this temporary increase doesn't offset the massive ice losses occurring in West Antarctica and along the peninsula, where warming ocean waters are undermining ice shelves from below. The continent's response to climate change illustrates the complexity of Earth's climate system and why understanding Antarctica remains crucial for predicting our planet's future. Deep beneath the Antarctic ice sheet, researchers have made another remarkable discovery that challenges our understanding of the continent's geological history. Using ground-penetrating radar and other advanced imaging techniques, scientists from Durham University have mapped extensive ancient river landscapes buried under thousands of meters of ice along a 3,500-kilometer stretch of the East Antarctic coastline. These ancient river systems, preserved in pristine condition for millions of years, provide insights into how Antarctica looked before it became the frozen continent we know today. These buried landscapes reveal that Antarctica once supported flowing rivers and possibly even forests, painting a picture of a dramatically different world from the ice-covered wasteland we see today. The discovery helps scientists understand how ice sheets form and evolve over geological timescales, knowledge that's critical for predicting how Antarctica might respond to future climate changes. The flat surfaces created by ancient river erosion also influence how ice flows today, potentially controlling the movement of glaciers and ice streams across vast areas of the continent. Antarctica's role as a natural laboratory for understanding extreme life extends beyond its hidden ecosystems. Researchers regularly discover microorganisms in environments that push the boundaries of what we consider habitable. In the dry valleys of Antarctica, where no rain has fallen for millions of years and temperatures rarely rise above freezing, scientists have found bacteria and other microorganisms that survive in conditions more extreme than those found on Mars. These discoveries have direct implications for astrobiology and the search for life beyond Earth. The continent also serves as an archive of Earth's atmospheric history, stretching back hundreds of thousands of years. Ice cores drilled from the Antarctic ice sheet contain trapped air bubbles that preserve samples of ancient atmospheres, allowing scientists to reconstruct carbon dioxide levels, temperatures, and other climatic conditions from long before human civilization began. Recent analysis of ice cores has revealed atmospheric conditions from 120,000 years ago, providing crucial data for understanding how Earth's climate system has functioned throughout different geological periods. One of the most intriguing recent discoveries involves mysterious openings that occasionally appear in the sea ice around Antarctica. These openings, called polynyas, can be enormous, sometimes covering areas twice the size of Wales. For years, scientists struggled to understand what caused these massive holes to appear in solid sea ice during the harsh Antarctic winter. Recent research has finally solved this puzzle, revealing a complex interaction between deep ocean currents, underwater topography, and atmospheric conditions that can temporarily create these windows in the ice. The polynyas serve as critical breathing holes for marine mammals like seals and whales, but they also play important roles in ocean circulation and climate regulation. When these openings appear, they allow heat exchange between the ocean and atmosphere that can influence weather patterns across vast areas. Understanding how and why polynyas form helps scientists better predict Antarctic climate dynamics and their global impacts. Antarctic research stations themselves represent marvels of engineering and human adaptability. The largest research station, McMurdo Station, operates like a small city during the Antarctic summer, housing over 1,000 researchers, support